Okay. This hopefully this will be our last segment. I'm looking at liquid measurements in oral syringes, and so a lot of times to accurately administer liquid medication to the patient is given in a oral syringe. So they have tips that are larger than the tips on the hypodermic syringe, so the needle cannot be placed on these particular type of syringes. After the dose is drawn into the syringe, a cap is placed on the tip that prevents leakage and prevents contamination. And there's something called adopt a cap. And this is an oral syringe that the cap is screwed on to the bottle and it contains a liquid, and the oral syringe is fitted into the other side of the cap, and it allows for easier drawing of that particular liquid. And these are, again, used for individuals who may not be able to swallow a tablet, a pill, and they are placed directly into the mouths of that particular patient, usually elderly or children. All right. Here we have a mortar and pestle. Here's my mortar, here's my pestle, here's my powder. And when you are mixing powders of unequal size, the smaller amount is what's called triturated with the equal amounts of the others. That mixture is then mixed with an equal amount of a larger amount of products. And this process is mixed until the entire mixture is completed. So this is done as part of a methodology of mixing powders, and this is called a geometric dilution. All right, solutions. A lot of times this is the most commonly compounded product. Sometimes it may be a clear liquid, not always colorless, that in which a drug is dissolved into. And something that's very important is the solubility of the drug. Must be known before attempting to dissolve a solution. For example, some drugs may not dissolve in water or in that particular liquid. So you have put them together. Now there's a problem because you can't unmix them. And so there are methodologies that allow for you to understand the solubility of a drug before mixing them. So if a drug is not suitable in a particular vehicle, then no amount of mixing will be helpful. And some solids can be mixed into a solution, but it must be what is called triturated. That means you put it in a little bit at a time, mix in, put a little bit more, mix in, put a little bit more, mix in, etc. Okay, and those are techniques that are used in compounding. All right. So here in a suspension, this two-phase system consisting of a liquid, a finely divided solid dispersed in a liquid. As you can see here, you have your graduated cylinder, you have your cap here, and you have two different types of suspension. One, you have what's called a floculating agent. These are electrolytes used in the preparation of a suspension that can form particles that could be easily be dispersed. Or sometimes you may need something to thicken the suspension. So these are ingredients used in the preparation of a suspension to increase the viscosity of the liquid. A very good example that you see that with many cough medication that they have used a thickening agent. It makes it a little bit easier to swallow, a little bit, take a little bit longer time, and allow for the medication to actually enter the patient. All right. As we mentioned, there's many different things that are added to the medication. You have flavors, you have sweeteners, you have colors. And basically, sweet is what everyone is going for. You see this in cough medicine. Sweeteners are colorless, odorless. It has a particular solubility in water at the concentrate needed for sweetening. allows for a pleasant tasting. Some medications have an aftertaste, so to prevent the aftertaste, sweeteners are used. Sometimes they have colors that's added, and the reason why they add coloring is because it makes the medicine a little bit more appropriate or appealing aesthetically to be taken. Dark colors are not used, like dark purple, navy blue, black, brown. But you see red, you see green, you see orange. You have something called a purple pill, Nexium. Again, to make it a little bit more appealing to take. So it's not for every formulation, and of course, you don't want to color sterile solutions. Usually, sterile solutions are clear. All right. Emulsions. A stable system consisting of at least two immiscible liquids. One is dispensed in the form of a small droplet throughout the other, and the other is a stabilizing agent. You have two types of emulsion. One, you can have oil and water emulsion, and water and oil emulsion. One of the challenges of a water and oil mixture is that you can have separation. And once you have separation, sometimes you don't really get a very good mix. Again, so there's a shelf life, and you may be cognizant of that shelf life for those type of medications. All right, so emulsifiers, a stabilizing agent in emulsion. Commonly used emulsifying agents include tegacath, sodium lauryl sulfate, sodium dialkyl, sulfur succinate, and polymers known as spans and tweens. So you have two major things that you find associated with the emulsion. Not only the emulsifier, but you have the prior emulsion, the initial emulsion to which the ingredient is added to create the final product. And sometimes you have at the initial state something called mucilage. And this is a wet, slimy liquid form at the initial state in a wet gum method. All right. Something that's also very important in medication is the formation of ointments. Here we talk about aseptic compounding and many different type of purposes to protect, antiseptic, emollient, antipyretic, chemotolytic, and astringent. Okay, and so basically we are talking about the ability to protect against insects. Sometimes it is used to prevent bacteria in the skin, anti-itching, and sometimes to prevent allergic reactions. And so an ointment will be placed on that particular individual. And this is usually for external use. And the making of ointments usually occur on an ointment slab and then transferred into an ointment jar with a label that's placed on it with how much to use and how to use it and given to the patient. Suppository. Remember we have talked about parenteral and enteral. And when we talk about enteral formulations, you have oral, buccal, sublingual, and rectal. Most suppositories will be for rectal use. You have three type of bases that is used, and here is what we call a mold in which a suppository is made. So you have oleaginous, primary synthetic triglyceride. You could have suppository that is water soluble, containing unglycerated gelatin or polyethylene glycols or PEGs, or you can have one that is hydrophilic with a mixture of oleaginous and water-based soluble bases. And again, when we talk about these suppositories, they are placed in the rectum, but you could also have vaginal suppositories. So, cocoa butter that is can be used and placed as a suppository. It has a well-known oleaginous base. At room temperature, cocoa butter is a solid. At body temperature, it begins to melt into a bland, non-irritating oil. It used to be a choice for suppository, but it's not really at this particular point in time. This particular type of suppository required refrigerated. And so now they have created synthetic triglycerides instead of cocoa butter. Even though they're more expensive, they're a much more they're much easier to use. So some of the newer compounds of suppositories are called fatty base and Witte-Spools. Okay, so they're newer base composed of mixture of fatty acids that do not have the formulation problems or expense. Okay. Here again, we're talking about water-based, water-soluble or medicinal-based suppositories. You have glycerinated gelatin or polyethylene glycopolymers. They are useful as vaginal suppositories. They dissolve slowly. They can be formulated by molding or comparison in a wide range of hardness and melting points. They do not melt the body temperature, but dissolve slowly to provide a prolonged release of the drug. And they have many different types of molecular weights, which is very important because it depends on the amount of medication the person needs. And so it could be adjusted for that particular individual. All right, so another thing that we have that is many times compounded. Sometimes you have seen the capsule, and if you break the capsule, you have powder in it. You have a hard gelatin capsule that consists of a body and a cap which fits firmly over the body of the capsule. And you have 8 different sizes. Okay, and those particular sizes is dependent on the amount of medication that is needed to be placed within them. Okay, when filling a capsule, when filling a number of capsules, use the punch method. You put the powder there. You have your gloves. Okay, if you have to touch the medication, like in this particular case, you want to make sure that you always have gloves, and so that no contaminants enter the medication. And as you can see here, you just take the capsule, punch it down, and you put it here. Then you put the other side on to the medication. Very important, labeling, record keeping, and cleanup. After compounding, the products must be labeled with a prescription label, and a careful record of the compounding operation should be kept. Once the compounding operation is finished, the equipment and area should be always clean. Everything should be returned to the proper places, and storage and compounding should never be rushed. You must take your time. So again, continuing on with the labeling, record keeping, and cleanup, regardless of the appearance of stability, all suspensions should be dispensed with auxiliary label, shake well. The QS abbreviation means to add as much as necessary to a specific amount. There are certain recommendations of the words that are used, and so you have to spell it out in some cases in order to prevent medication error, and refer to the standard reference work on that particular subject. As, for example, there's a book called Remington, The Science and Practice of Pharmacy, which allows for you to understand how suspensions are made. And finally, there's certain terms that you should remember. It's very important. Aliquot, arrest knob, beyond use state, calibrate, chapter 795, 797, compounding record, compression molding, emulsifier, Brinker-Cottes, floculating agents, formulation record, and fusion molding. Thank you. And this concludes chapter